relationship. So then now we studying about that. Special properties of sampling distribution. Now, right, various formats of sampling distributions, the section 2.4. Other currently various formats of sampling distributions. So then there are common properties of sampling distribution. So there are various types of sampling distributions. Sampling distributions keep here. Sampling distribution of sample means. Example and difference between two sample means, sampling distribution of sample proportion and difference between two sample proportions. Mainly there are 4 types of sampling distributions we are using. So all calculations after this. So in case of confidence intervals and testing hypothesis, those 4 types of sampling distributions. So now there are even that if it is a sampling distribution, sampling distribution, so then we have drawn samples from various types of populations. Populations. So then we can draw samples from normal populations, non-normal populations, and then that population, the variance is known, and sometimes variance is unknown, and then the size of sample. So there are a lot of factors are there. Common properties api දැන් ගන්න sample එක ගන්න අපි ගත්තොත් එහෙම මොකද sample එක අපි ලබා ගන්න population එක එක විදිහේ වෙන්න පුළුවන්. Normal වෙන්න පුළුවන්, non normal, there may be a normal population or non normal population. ඒ වගේම ඒ ගන්න population එකේ variance එක දන්නවා වෙන්න පුළුවන් නැති වෙන්න. ඒ වගේම ගන්න sample එකේ size එක. Now here we divide the samples are with 2 different so then as 2 different ways as the large and small samples. Large samples the size of sample whose is greater than or equal 30. So then we consider them as large samples. අපි large samples කියලා කියන්නේ sample size එක 30ට වඩා වැඩි ඒවා. 30 හෝ වැඩි ඊට අඩු ඒවා small samples. ඒතකොට මේ වගේ විවිධ විදියට අපිට sample එකක් ගන්න පුළුවන් වෙනවා. ඒ කියන්නේ normal population එකෙන්ද non normal එකෙන්ද. එතකොට මේ common properties ටික ටික වෙනස් වෙලා අපිට එනවා මේ එක විදිහේ sampling distributions ටිකක්. ඒ ටික තමයි මම දැන් මෙතන විස්තර කරන්න යන්නේ, the various formats of sampling distributions. එතන මේකේ පළවෙනි ටික තමයි ගොඩක් වැදගත්, sampling distribution of sample means. මම CAT exam එකකටත් ඒ ටික කළා. මොකද ඒකේ ඔයගොල්ලන් අහලා තිබුණේ that area only. So they are going to consider about the area sampling distribution of sample means only. Sample means කියන එක විතරයි මම හිතන්නේ මේවා කරනවා කියලා තියෙනවා. නමුත් තව final exam එකට ඒ ටික ඔක්කොම තියෙනවා. Difference between two means, proportions and difference between two proportions. ඒ ඔක්කොම ටික තියෙනවා under 2.4. So what are these properties? So then there are small differences in between them. එතකොට මේ common properties වල අපිට පොඩි වෙනස්කම් ටිකක් තියෙනවා මේ sampling distributions ටිකේ. එතකොට so we have a very clear idea about the various formats of sampling distributions. So then in case of confidence intervals, අපි කරන confidence intervals ඒ කියන්නේ කල්පිත පරීක්ෂා සහ විශ්‍රාම්භ සීමා සහ කල්පිත පරීක්ෂා hypothesis testing. එතකොට මේ දෙකේදීම අපි මේ එක sampling distributions ගන්නවා. එතකොට formulas වල තියෙනවා පොඩි පොඩි වෙනස්කම්. එතකොට අපි හරියට ලියන්න ඕනේ. We must write the correct formula. ඒ හින්දා අපි ඒ ගැන හරියටම දැනගෙන ඉන්න ඕනේ. Now this is the most important part of this lesson. What are the various formats of sampling distributions? 2.4. 2.4 එක හම්බුණාද? Have you got it? The section 2.4 මං කලිනුත් ඒවල තියෙනවා ඔයගලන්ට. 2.4 lesson එක.
Yes madam.
මං දැනුත් එව්වා.
Yes madam. හම්බුණා.
හරි. Now we'll see the 2.4 various formats. එතකොට මේ තියරි කොටස ටිකක් හරියටම ඔළුවට ගන්න බලන්න. මේක ඔයගලන්ට කීප සැරයක් කරනකොට ඔයගලන්ට මේක ටිකක් පුරුදු වෙනවා. මේ ගැන 2.4 various formats of sampling distributions. First, I am going to explain sampling distribution of sample means. අපිට ගොඩාක් ගණන් එන්නේ මේකෙන් තමයි sampling distribution of sample means. ඒතර අපි මේක දැනගත්තාම මේකෙන් පස්සේ තියෙන difference between two means කියන එක මේකම බේස් කරගෙන අපිට ඉගෙන ගන්න පුළුවන්. ඒ හින්දා මේක තමයි වැදගත් මේක sampling distribution of sample means. Sampling distribution of sample means. You know what is sampling distribution of sample means. අපි example එකට ගත්තෙත් මේකම තමයි. What is that? That once all possible random samples with same size are drawn and compute the means of all these samples, the probability distribution of these sample means is known as sampling distribution of sample means. අපි මේක තමයි අපි so we have taken as our example sampling distribution. So now mean of that sampling distribution, variance of that sampling distribution, and the standard error or standard deviation of the sampling distribution. So there are some standard notations. මෙන්න මේ ටිකට අපි සම්මත අංකන ටිකක් පාවිච්චි කරනවා. So notations used කියලා තියෙනවා. Notations used. So now all four types of sampling distributions I am going to discuss. ඒතර sampling distributions හතරක් මම කියන්න යනවා. So under various formats, the difference between two means, proportion and difference between two proportions. මේ හැම එකේම mean and variance has there are some special notations. ඒ notations වල තියෙනවා there is a particular pattern එකක් තියෙනවා. ඒකෙන් ඔයගලන්ට so you can understand well what is that. Now first of all we'll see what are the notations here we are using is notations used. So what is the mean of the sampling distribution of sample means? The mean, that is the expected value. So EX bar, expected value of the sampling distribution of sample means, we denoted them as mu X bar. This is just a notation. Now that is called mu X bar. හැමදේම හරියටම ඉගෙන ගන්න. එතකොට අපිට හරි lazy. So once you are going to dealing with all these the sampling distributions. So then variance of a sampling distribution of sample means. So what is VARX bar? Variance. VARX bar is denoted as sigma square X bar. Now this is the variance of the sampling distribution of sample means. So then standard error, that is the standard deviation. Standard deviation of sampling distribution of sample means. So that is called standard error. standard error standard deviation. Standard deviation. Standard deviation. So that is standard error. Standard error or standard deviation is what? Square root of variance x bar. Square root of variance x bar is denoted as sigma x bar. So what are the three notations? Mean of a sampling distribution we denoted as mu x bar. Variance is sigma square x bar, and standard deviation or standard error is sigma x bar. Now these are the three notations we are using. Sampling distribution of sample means. Right. Then common properties. Common properties of this one. The common properties. Once again, remind it. Keep once we are repeating it several times. Now, this is the most important one also, because why? So, a lot of questions are from sampling distribution of sample means. Once you go through your past papers will be questions, maybe means right. Then the common properties, once again, you can remind. The common properties. So mu x bar, what is that? So mean of the sampling distribution of sample means is equal to the population mean mu. Apurvali padam karaganda mu x bar is equal mu yagi notation solinatu. What is that? Mean of this sampling distribution is equal to the population mean mu. So then what is the second property? Second property regarding the variance. So then under three conditions. What are the three conditions? So when your population is infinite, and sampling without replacement. And what is your sampling fraction? Simple N over capital N less than 0.05. So what will happen? So the variance, that is sigma square x bar, is equal, what is that? Population variance divided by sample size. So then it is under, so you have drawn your sample from an infinite population, or so if you take, sampling with replacement, or sampling fraction, simple N over capital N is less than 0.05. So then what is the variance of that? Population variance divided by sample size. Otherwise, so at least one of these conditions. So then its variance is equal population variance over sample size. Otherwise, make any factor. So then that is from a finite population. Population is finite. Otherwise, population is finite, or sampling without replacement. Sampling without replacement, or the fraction. Simple N over capital N greater than or 0.05. So what is this variance? This variance is equal correction factor. Capital into population variance over sample size. These are the three common properties. Its mean is equal to the population mean mu. Its variance under one of these conditions is population variance over sample size. Otherwise, population variance over sample size into a correction factor. Simple mean population mean mu, and variance under these three conditions from an infinite population, or sample with replacement, or fraction is less than 0.05, it's equal population variance over sample size. Otherwise, you are making better. population variance over sample size into a correction factor. So that is very simple way. Now these are the common properties of sampling distribution of sample means new notations and their common properties. So I have given this detail in my note. Right. So now formats of sampling distribution of sample means. So so here I'm going to explain 5 different cases. One of the 5 different cases. So then now whether we are going to see whether our population is normal or non-normal, population variance is known or unknown, and conditions. So then these common properties as small differences. Podi differences under 5 cases. Cases පහකට මම විතර දාලා තියෙනවා. ඒ ටික හොඳට මතක තියාගන්න. එතකොට ඒකම අපිට අපි නිතර නිතර ගණන් හදනකොට once we are using this, so අපිට නිකම් මේ පටපාඩමක් වෙනවා. So now you just look at what are those 5 cases. මම හිතන්නේ මම chat එකකට කරා ඔයගලන්ට පොඩි idea එකකුත් ඇති. So what are the various formats of sampling distributions? Right. Common properties and notations are okay. Common properties and notations. Is it okay, I think?
Okay, madam.
Okay, right. Now we'll see under various conditions. මම මේක විස්තර කරලා තියෙනවා note එක. එතකොට බලා ගන්න note එක මම board එකේ දාන්න කියලා තියෙනවා.
Yeah, so it's thing I based on the modern the APIs
Case one. Case one. Case one. So 3 conditions are population is normally distributed. So we are going to make samples from normal population. Population is normally distributed. Normally distributed. And population variance is known. Sigma square is known. Population variance is known. And so we draw any size of sample, any size of sample. Here we are not dividing them as the large or small. Own a size of sample. For any size of sample. For any size of sample. So what is that? So there is the new thing now we are going to learn. Sampling distribution of sample means are normally distributed. May properties now this is a normal distribution. It's normally distributed with mean mu, that is population mean, and variance sigma square over n. Sigma square over n. So it has now here, if our population is finite and the 3 conditions, or sampling without replacement and so the sampling fraction greater than or equal 0.05 have a variance to be multiplied by the respective correction factor. Condition so these 5 cases goes up to 10. So it is too much complicated. So therefore, now if the 3 conditions from a finite population or sampling is without replacement and sampling fractions are greater than or equal 0.05, so this variance to be multiplied by the respective correction factor. Correction factor, what is that? Capital N minus simple n, n minus 1. When making value, I can variance. So now I am going to make a delta. So this part only. So under that conditions, we must multiply them by a respective correction factor. So this one becomes too complicated. So then the Z value. So then if it is a normal distribution, the various calculations we are going to do, confidence intervals and hypothesis testing and all. So these normal distributions, so then we have a Z value. So what is the Z value of this normal distribution? Z is equal to x bar minus mu square root of this. Sigma over root n. මේ තියෙන variance එක මේ තියෙන standard deviation. Z value of this one. So then what is your case 1? So you drawn a sample from a normal population with a known variance, and once you take any size of sample, sampling distribution of sample means are normally distributed with mean mu and variance sigma square over n. Its Z value is equal x bar minus mu sigma over root n. Now this is your case 1. This is your case 1. Non-normal population with known variance. So you drawn any size of sample. What about your case 2? What about your case 2? Case 2. Case 2 is again population is normally distributed. Population is normally distributed. Again a normal population. Population is normally distributed. Population is normally distributed. Normally distributed. And population variance is unknown. Have a population variance එක දන්නේ නැහැ. So this is unknown. And for large samples, now here we are going to draw a large sample. For large samples, what are the large samples? Size is greater than or equal 30. එතකොට මෙන්න මේක වෙනස් වෙනවා. This sampling distribution is so then has a small change. Sampling distribution of sample means once again normally distributed with population mean mu. What about your variance? The sigma square is unknown. Sample variance over sample size. Now here we replace the population variance by a sample variance. Why? This population variance is known, not known. මේකෙදි අපි මේ population එකේ variance එක දන්නේ නැති හින්දා so now we replace them by our sample variance over n. So then now what is our Z value? Now our Z value is equal x bar minus mu. Now it is S over root n. You have to write this correct formulas in confidence intervals and hypothesis testing. එතකොට මෙතන S තියෙන්න ඕන. දැන් sigma over root n දැම්මොත් එතන වැරදි. Your formula goes to be wrong. Sometimes your answer may be correct. So then you lost some marks. Anyhow, you have to know exactly really what will happen. Now this is from unknown, from a normal population with unknown variance. So once you draw a large sample, now our sampling distribution turns like that. It is not sigma square over n. Common property එකේ අපි එහෙම කිව්වට මෙතෙන්දී ඒක s square over n වෙනවා and then now z value goes to as s over root n. That is our case number 2. That is our case number 2. So what about your case 3? All 5 cases are there. What about your case 3? Case number 3. මේකම වෙනස් කරනවා. Case number 3. Case number 3. Case number 3. Population is normally distributed. Again, sigma square is unknown. Sigma square is unknown with unknown variance. Case 3 is unknown. For small samples, මෙතන ගත්තේ large samples. Now I am going to take a small sample. For small samples, not any size of sample. So then case 3 is for small samples. So what are the small samples? These are the samples with size less than 30, n less than 30. What will happen now? Now look at this. So in case 3, sampling distribution of sample means does not follows a normal distribution now. ඒක normal distribution එකක් නෙමෙයි. Does not follows a normal distribution now. So it's a distribution which is known as T distribution. අපි ඒකට කියනවා T distribution කියලා. So with population being mu and variance is square over n. Variance is square over n. Now here also the population variance is unknown. මේකෙත් අපේ population variance එක දන්නේ නැති හින්දා so we replace them by our sample variance. But it is not a normal distribution. හැබැයි ඒක normal distribution එකක් නෙමෙයි. So there is one, the distribution which is known as t distribution. Now for this calculation, we are not using our z value. Now we are using our t value. What is our t value? Z value that in t. T value x bar minus mu s over root 10. S over root 10. That is your case 3. So then if any question is from case 3, if you follow the normal distribution, your answer is completely wrong. එතකොට අපි normal distribution එක t distribution එක තියෙන එකක් වෙනකොට normal එක value දැම්මොත් ඒකේ value එක දැම්මොත් එහෙම අපේ උත්තරේ පිටිම වැරදිලා යනවා. අන්න ඒ හින්දා අපි දැනගන්න ඕනේ. So when we are going to use our t distribution, there is one distribution as t distribution. So then still we are not using it. අපි තාම ඒක පාවිච්චි කරේ නෑ. Now just now you think about that is a t distribution. ඊට පස්සේ මම මේ note එකේ දාලා තියෙනවා. So then so description about a t distribution. අපි ඊළඟ කොටසේදී බලමු කොහොමද t distribution එක පාවිච්චි කරන්නේ කියලා. So in this section no need to use a t distribution. You just know there is a distribution is available as t distribution, and so then the small description about that. මම ඒක ගැන පොඩි විස්තර ටිකක් දාලා තියෙනවා. So then unless the sample size is sufficiently not large, that is n is less than 30, standard deviation of the sampling distribution of sample means should be estimated using the sample standard deviation, and then sampling distribution of x bar does not further normally. එතකොට මෙතෙන්දි වෙලා වෙන්නේ අපේ population variance එක දන්නේ නැති නිසා අපි ඒක වෙනුවට sample variance එක ගත්තාම, so then if for a large sample that's okay. Large sample එකක් ගත්තාම it follows a normal distribution, but for a small sample, හැබැයි small sample එකක් ගත්තාම it is not normal. So in such situations, sampling distribution of x bar falls in a t distribution. එතකොට ඒක normal distribution එක ටිකක් සමාන. So then one distribution, so which is known as t distribution. It was බලන්න properties of t distribution. So then which kind of distribution is your t distribution? So there are two methods are different to follow up your normal distribution and t distribution. ඔයගොල්ලෝ normal distribution එක බලන විදිහට නෙමෙයි t එක බලන්නේ ඒක පොඩක් වෙනස්. So now we can do it in our next section. So what is that? It is also symmetrical distribution as well as normal distribution. හැබැයි මේක normal distribution එක වගේම, so then with the bell shape, the symmetrical distribution, symmetrical around mean 0. So dispersion of t distribution is greater than that of the normal distribution. Dispersion. අපි සිංහලෙන් මොකද කියන්නේ විසිරීම කියලා. So that is more flatter than that. So then that is the short and wide. එතකොට සාමාන්‍යයෙන් අපි normal distribution එකට වඩා මේක ටිකක් අර වැඩි දුරකට විසිරීලා තියෙනවා. Short and wide. මෙන්න මේ වගේ ටිකක් අර පැතලි. අපි සිංහලෙන් කියන්නේ පැතලි. So that is short and wide. So then that the normal distribution. The normal distribution එක ටිකක් මේ වගේ. This is your normal. So t distribution is well spread out. So that the normal distribution. Normal distribution එකට වඩා ටිකක් සිංහලෙන් කිව්වොත් විසිරීලා තියෙනවා. So then the dispersion of t distribution is greater than that of normal distribution. Since this is the special property of t distribution. මේ තුන්වෙනි එක තමයි t distribution එකේ තියෙන වෙනස්ම property එක. So since the t distribution depends on the sample size n, so relevant areas have been tabulated and according to the n-1 degree of freedom. So t distribution is not a single distribution. Normal distribution na, so we all have same areas, standard normal distribution. So there are set of t distributions. අපි කියනවා t ව්‍යාප්ති කුලකයක් තියෙනවා සිංහලෙන්. So there are set of t distributions depending on the sample size. ඇත්තටම depending on the sample size කිව්වට n-1. So n-1 කියන එකට අපි කියනවා that is called degree of freedom. සිංහල වචනේ සුචලන අංකය. So there are some set of t distributions depending on degree of freedom. Degree of freedom is n-1. So what will happen? So your n-1 is a small value. Let's say like 2, 3. ඒ කියන්නේ sample size එක 4 නම් degree of freedom is 3. sample size is 10, degree of freedom is 9, like that. So then your degree of freedom is the small value, so then it is more flatter. Value. So then like your degree of freedom is a value like 10, 12, 15, again sample size 16, 13, so then that is it's actual flat neck. So then it goes to narrow. And again, your degree of freedom is closer to 30. Theater keep to like 29. So then it is more symmetrical. So then there are some set of the T distributions depending on degree of freedom or sample size. So then if your sample size is 5, sample size is 5 now, your degree of freedom is 4. Now this is the degree of freedom 4. Median degree of freedom 4. Degree of freedom is 15. 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 That is sample size is 16. Or degree of freedom is 29. Or normal distribution. Degree of freedom is 29. So like that. So then there are some set of T distributions. The third property, since the T distribution depends on the sample size n, relevant areas have been tabulated and according to the degree of freedom. So areas of T distribution with various degrees of freedom. Now we'll see it later. So then no worries about how to use T distribution now, just to have an idea. So what are the properties? So there are some similarities as normal distribution and differences. So it is same as symmetrical distribution around as mean 0. So then it is the more flatter. So dispersion of them is dispersion of them is greater than that of the normal distribution, and there are set of T distributions is available depending on the sample size. That's all. It's not a single distribution. There are some set of distributions. Right. Now this is under case 3 is what? So then the population is normally distributed and with unknown variance. So once we draw a small sample, so it does not follow a normal distribution. So it follows a distribution which is known as T distribution. Right. So then the next two cases, case number 4 and case number 5. So then they are from non-normal populations. Population, they are not normally distributed. So now we are going to, sampling from non-normal populations. Sampling from non-normally distributed random variables. The sampling distribution of sample means, associated with non-normal population is approximate to the normal distribution when the sample size is n is greater than or equal 30 in accordance with the central limit theorem. Make it properties figure. So then is based on a particular theorem that is called central limit theorem. So once we drawn samples from a non-normal population, so then properties of sampling distribution is given by one particular theorem which is known as central limit theorem. Single madhya seema prameya කියලා. එතකොට අපි කියනවා මෙන්න මේ මධ්‍ය සීමා ප්‍රමේය තියෙන විදිය අනුගමනය කරනවා. So once you are going to the sampling from a non-normal population, ඒ කියන්නේ ප්‍රමත නොවන සංග්‍රහණයකින් අපි samples ගන්නවා. So what is your central limit theorem? Once the size of a sample drawn from any population with any population, it is non-normal. Any population with mean mu and variance sigma square is sufficiently large. Especially, we must draw on all samples with large, sufficiently large. The sampling distribution of sample means approximately follows a normal distribution with mean mu and variance sigma square over n. So then what will happen? What is the central limit theorem says that? So now this sampling distribution is not that it is approximately normally distributed. Normal distribution approximately normally distributed. There is another condition. We must draw on all our large samples. Make it the small samples, we must take the all large samples. So how we summarize this case number 4 and 5? Then case number 4 and 5 is accordance with the central limit theorem. Why? We are going to sampling from non-normal populations. Let's case number 4. Case number 4. Case number 4. Population is not normally distributed. Population is not normally distributed. Population is not normally distributed. Sigma square is known. So now this is non-normal population, but population variance is known. Population එක normal උනේ නැතුවට ඒක variance එක දන්නවා. For once we draw a large samples, what will happen? Sampling distribution of sample means case number 4. Case number 4, sampling distribution of sample means are approximately normally distributed. Normal distribution is but approximately it means mu variance sigma square over E. The difference here is it is approximately normally distributed. Approximately. So again, approximate not make any Z value because now same as case 1 is Z value x bar minus mu sigma over root 10. Approximate not Z value we're going to then. So now this is approximately. So what is that? So once we compare with case 1 and case 4, what is the difference? Case 1 for any size of sample. Have I make it? So then for large samples only. Large samples only. But set of formulas are same. Now this is approximately normally distributed and Z is equal x bar minus mu sigma over root 10. Make a කොහොමත් සමානයි case 1 එකට. හැබැයි case 1 is valid for any size of samples, but case 4 is only for large samples according to the central limit theorem. Central limit theorem එකේ කියනවා අනිවාර්යයෙන්ම අපි ගන්න ඕනේ large samples. So what is our last one? The final case. Case number 5. Population is not normally distributed. Population again non-normal. Population is not normally distributed. Case number 5. Case number 5. Case number 5. Population is not normally distributed. But sigma square is unknown. Sigma square unknown. Make a sigma square known. Make a sigma square unknown. Now here for large samples, not small samples. Again, you are looking at large samples. For large samples, that is n greater than or equal 30. What will happen once again? So sampling distribution of sample means are approximately normally distributed with mean mu. What is your variance? S square over A. Make a හරියටම case 2 එකමයි. හැබැයි මේක approximately. Approximately normally distributed. So the result value is same as case 2. X bar minus mu. X bar minus mu. S over root 10. S over root 10. Case number 5 is the non-normal population. Population is not normally distributed, but population variance is unknown. For large samples, sampling distribution of sample means are approximately normally distributed with mean mu and variance S square over N. Make a case 2 එකටම සමානයි. හැබැයි මේකදී approximately normally distributed. So one more thing I have given the case number 6. So then we are not using them for calculations. Calculations වලට අපි මේක පාවිච්චි කරන්නේ. What is your case number 6? Population is not normally distributed. Case number 6. Case number 6. Population is not normally distributed. Sigma square is equal known or unknown. Unknown. So what about for small samples? When non-normal population again. So once we draw a small sample, so what will happen? Sampling distribution is not defined. Sampling distribution is not defined. Sampling distribution of sample means is not defined. Is not defined. Make अर्थ दाखवला नाही. Central limit theorem එකේ ඒකයි කියන්නේ you must draw all large samples. Now these are the 5 different cases. Case number 6 is available, but we are not using them for calculations. So with small differences, so there are some differences of the formulas. සමහර ඒවා sigma square තියෙනවා, සමහර ඒවා s තියෙනවා. So some distributions are normally distributed. Under case 3 it is a T distribution. මේ වෙනස්කම් ටික අපි හරියටම දැනගෙන ඉන්න ඕනේ. So what are the differences in all 5 cases? Sixth one is not defined. Highly එක අපි define කරලා නැහැ. Right. What about that? So do you have any questions? මොනවා හරි ප්‍රශ්න තියෙනවද මේකේ? තේරුණාද නැත්නම් ඒක? What about this 5 cases? තේරුණාද?
Okay.
Are there any questions? Is it okay? හරිද?
मैडम मरा
අහන්න
මොකද්ද
මම ඔයගොල්ලෝ දාන මැසේජ් මට පොඩක් පේන්නේ නැහැ මේකේ. පොඩක් කතා
मैडम
කරලා
फोरम
අහන්න
में
මොකක් හරි ප්‍රශ්නයක් තියෙනවනම්.
मैडम मरा नම
මොකද්ද?
මොකද්ද කිව්වේ මේ ෆෝරම් එකක් ගැන කිව්වේ ඒ නම මොකද්ද ඒකේ
මොකද්ද?
තියරිටි ෆෝම් මොකද්ද අර ඩිෆයින්
Central
කරලා
limit
තියෙනවා
theorem එකද? Central limit theorem ද?
තියරම් නේ හරි සෝරි
ඔව් ඒක central limit theorem. ඒ කියන්නේ ඒකේ ලොකු දෙයක් නෑ. ඒකෙදි වෙන්නේ අර population එක normal distribution එකක් නෙවෙනකොට අර large samples ගන්න කියලා ඒක theorem එකක් විදිහට දාලා තියෙනවා. අපි ඒකට කියනවා according to the central limit theorem. අනිත් එක මේ sampling distributions එතකොට හරියටම normal distributions නෙමෙයි. approximately normally distributed. එච්චරයි වෙනස. ඒක වෙනම theorem එකක් විදිහට දාලා තියෙනවා. අපි ඒකට කියන්නේ central limit theorem කියලා. සිංහලෙන් කියනවා මධ්‍ය සීමා ප්‍රමේය කියලා. මධ්‍ය සීමා ප්‍රමේය. ඒ කියන්නේ මධ්‍ය සීමා ප්‍රමේය කියන එක දන්නේ නැති වුණත් ඔයගොල්ලන්ට මේක ගණන් හදන්න පුළුවන්. මොකද මේ එකම වගේ ෆෝමියුලාස් ටිකක් නෙන්නේ. හැබැයි ඒක ඔයගොල්ලෝ දැනගෙන ඉන්න ඕනේ. ඒ හින්දා තමයි ඒක මම දාලා තියෙන්නේ. central limit theorem එක. ඒ කියන්නේ මධ්‍ය සීමා ප්‍රමේය කියන වචනේවත් දන්නේ නැති වුණත් ඔයගොල්ලන්ට ගණන් හදන්න අවුලක් නැහැ. non normal population එකක් වුණත් දැන් case 2 එකයි case 5 එකයි සමානයි. එකම විදිහේ තියෙන්නේ. හැබැයි අර හරි දැන් T distribution එක පාවිච්චි කරනකොට අපි කොතෙන්දද පාවිච්චි කරන්නේ? අපි අන්න ඒව දැනගෙන ඉන්න ඕනේ ඉඳ තමයි මේ ටික වෙන වෙනම ඉගෙන ගන්න. නැත්නම් අර මුල ටික ඉගෙන ගත්තත් අපිට ඇති. ඒනට එහෙම කරන්න බෑ. මොකද සමහර ඒවට අපිට T distribution එක පාවිච්චි කරන්න වෙනවා. ඒතර මේ තමයි sampling distribution of sample means කියන එක. එතකොට මේකෙන් තමයි ගොඩක් වෙලාවට අපිට බලාපොරොත්තු වෙන්න පුළුවන් ගණන්. හැබැයි අපිට එහෙමම කියලා බෑ. ඔයගොල්ලන්ගේ අර CAT exam එකේ නම් මේක විතරයි කියලා දීලා තිබ්බා. අර කියන checking areas ද testing areas ද මොකද්ද කියලා ඔයගොල්ලන්ට මොකක් හරි document එකක මම දැක්කා තියෙනවා. sample means කියන එක විතරයි මේකේ check කරන්න කියලා. හැබැයි ඒ විතරක් නෙමෙයි. There are 4 types of sampling distributions. ඊළඟට තව එකක් තියෙනවා sampling distribution of difference between two sample means. That is x bar 1 minus x bar 2. මේ තියෙන x bar විතරයි අරක x bar 1 minus x bar 2. එතකොට x bar 1 minus x bar 2 කියන එකෙත් මේ cases පහම තියෙනවා. මේ ඒක වෙනම මතක තියාගන්න යන්න එපා. මොකද ඒක ටිකක් calculation සමාරුයි. මේක මතක තියාගෙන මේකම extend කරන්නයි තියෙන්නේ. ඒ කියන්නේ මේකේ තියෙන එකයිනේ ඒකේ දෙකක් තියෙනවා. ඒතර මේ දෙක ලියා ගන්න තමයි අපි පොඩ්ඩක් දැනගන්න ඕනේ. මම මේකේදී ඒක විස්තර කරන්නම්. ඒ වගේම ඒක අර දැන් CAT exam එකට ආවේ නැහැ කියලා අපිට final එකට මේක ඉන්නේ නැහැ කියලා කියන්න බෑ. මොකද ඔයගොල්ලන්ගේ syllabus එකේ තියෙන නිසා මම ඒකත් කරනවා. එතකොට ඒක ගොඩාක් අමාරුවෙන් නිකන් හිතට වදයක් වෙන විදිහට මතක තියාගන්නේ නැතුව මේකෙම extension එකක් විදිහට මතක තියාගන්න. මේක හොඳට මතක තියාගන්න මේ cases පහ. එතකොට මේකේ තියෙන formulas අපි දෙකකට extend කරන එකක් තමයි difference between two sample means කියලා එන්නේ. ඉඳා මේ conditions ටිකමයි තියෙන්නේ. මේකෙම extension එකක් extend වෙලා තව එකක් දික් වෙලා තියෙන විදිහට තමයි මතක තියාගන්න ඕනේ. But in case of proportion and difference between two proportions, so there are no conditions. ඒවා එකයි තියෙන්නේ. එහෙනම් කිසිම ගැටලුවක් නැහැ. ඒ දෙක එච්චර ගැටලුවක් වෙන්නේ නැහැ. මෙන්න මේක තමයි පොඩ්ඩක් අමාරු. මේක වෙනම මතක තියාගන්නේ නැතුව අරකේ extension එකක් විදිහට මතක තියාගන්න. Right. Next one is sampling distribution of difference between two sample means. එතකොට මේවා ඕනේ නෑ කියලා අහගෙන ඉන්න නැතුව ඉන්න එපා. මේවා ඕනේ. මොකද වෙන ගාණක් පොඩක් වෙනස් වෙලා આવොත් ඕගලන්ට ටිකක් අමාරු වෙනවා හදාගන්න. හරියට තියරි එක දන්නේ නැති වෙනකොට. Sampling distribution of difference between two sample means the next set of distributions. Sampling distribution of difference between two sample means. Sample means. Oh, no. Hold on, thank you. Right. So now again set of notations. The notations used. Notations used. So what is the mean of that distribution? Mean. Make a mean that is expected value of distribution. The probability distribution of the values that can be taken by the difference between means of all possible independent samples drawn in random from two populations is known as sampling distribution of difference between two sample means. The notations used X bar X bar 1 minus X bar 2, X bar 1 minus X bar 2 has a notation mu X bar 1 minus X bar 2. So variance VAR X bar 1 minus X bar 2 is denoted as sigma square X bar 1 minus X bar 2. Standard deviation, standard error, standard deviation or standard error. Standard error is square root VAR X bar 1 minus X bar 2 is sigma X bar 1 minus X bar 2. Many notations. Set of notations we are using. Difference between two sample means. Difference between two sample means. Right. So then common properties. It was a common properties. Common properties of this distribution. Common properties. Make it common properties tuna. Common properties. Common properties. Mu X bar 1 minus X bar 2. Make a mean maker. Mu 1 minus mu 2. Population mean mu. Make it mu 1 minus mu 2. Make a difference. Difference between two sample means that mean is equal mu 1 minus mu 2. The difference of the population, mean of population 1 and population 2. Mu 1 minus mu 2. Here we make a variance. So under three conditions, population is infinite, sampling with replacement, and sampling fractions. Make N1 over N1 less than 0.05, N2 over capital N2 less than 0.05. Many conditions to make a variance X bar 1 minus X bar 2 is equal sigma 1 square over N1 sigma 2 square over n2. ඒ කියන්නේ පළවෙනි population එකේ variance එක divide by its sample size. දෙවෙනි population එකේ variance එක divide by n2. sigma square over n කියන එක n1 n2 කියන මෙතන දෙකකට කැඩලා තියෙනවා. Now that is for so then the population is infinite sampling with replacement and the fractions are less than 0.05. So then again the otherwise කියන්නේ so then variance of a sampling distribution of difference between two sample means sampling without replacement population is finite මේක අනිත් පැත්ත. So once we draw from a finite population is finite sampling without replacement and sampling fractions less than 0.05 0.05. What will happen? මේ දෙකට මුලින් දානවා their respective correction factors. So your variance is variance x bar 1 minus x bar 2 correction factors දෙක දාන්න මුලින්. Capital N1 simple N1 minus 1 into sigma 1 square over N1 plus N2 minus simple N2 minus 1 into sigma 2 square over N2. මේවා මේ notations පාඩම් කරන්න එපා. මම කිව්වා වගේ common properties මොකද්ද single sample එකේ sample means its mean is equal population mean mu. Make it mu1 minus mu2. What is its variance under first three conditions? So population variance over sample size. එතකොට මෙතෙන්දී population 1 over sample size 1, population 2 over sample size 2. Otherwise, any three conditions. So we have to the population variance over sample size multiplying by the respective correction factor. Correction factor එක දාන්න. ඒ වගේ වචන වලින් පාඩම් කරලා තියාගන්න. මේවා n1 1 minus equal n1 මේවා පාඩම් කරන්න ගියොත් ඔයගොල්ලන්ට පිස්සු වැగిලා නවතින්නේ. ඒ හින්දා අර මම කියපු විදිහට in logical you have to think it. තර්කානුකූලව හිතලා හරියට දාන්න. මෙතෙන්දි වෙන්නේ population variance over sample size. දෙකකදී මේක දෙකකට දාන්න. අනිත් එකේදී වෙන්නේ we have to multiply by a correction factor. ඒක මුලට correction factor එක දාන්න. එච්චරයි කරන්න තියෙන්නේ. Right. Now these are the common properties. So the difference between two sample means. මේක තමයි ටිකක් අමාරු. අනිත් ඒවා එච්චර අවුලක් නැහැ. අනිත් දෙකට conditions නැහැ. Proportion and difference between two proportions there are no conditions. Right. Now ආපහු සැරයක් අපි so now we analyze all five cases. ඔයගොල්ලෝ හරියට හිතුවොත් මේක ඔයගලන්ට මේ නිකන් තනියම ලියා ගන්නත් පුළුවන් සයිස් එකක් තියෙන්නේ. ඒ නිසා පොඩ්ඩක් ඒක බලලා හරියටම මේවා කරගන්න. පොඩ්ඩක් Right. Then all five cases. Case number 1. ඒතර අනිත් ටික ඔයගලන්ට ආපහු සැරයක් මතක් වෙනවා. Single sample එක. Case number 1. Pattern එක identify කරගන්න ඉස්සම දෙකම කරගෙන ගියාම ඔයගලන්ට ඒක අඳුර ගන්න පුළුවන්. What is case number 1? The populations are normally distributed. Case 1. Populations are normally distributed. Normally distributed. So both variances are known. So Mangana sigma 1 square, sigma 2 square, known. Any size of sample. Any size of samples. Any size of samples. So what is the distribution? So sampling distribution of difference between two sample means are normally distributed with mean mu1 minus mu2, mu1 minus mu2. What is the variance? Sigma 1 square over n1 plus sigma 2 square over n2. Arakema extension එක. So then what about your Z value? Z value is equal x bar 1 minus x bar 2 mu 1 minus mu 2 over square root of this. Make it sigma 1 square over n1 plus sigma 2 square over n2. When the case 1. Case 1. Arakema extension. Case 2. Again, same set of conditions. Case 2. Case 2, same set of conditions. Case number 2. What is that? Populations are normally distributed. Populations are normally distributed. Populations normally distributed. Sigma 1 square, sigma 2 square unknown. And for large samples. For large samples. So what are the large samples? N1 greater than or equal 30, N2 greater than or equal 30. What is that? X bar 1 minus x bar 2, x bar 1 minus x bar 2 is normally distributed with mean mu1 minus mu2. What about your variance? Make them S1 square over n1 plus S2 square over n2. Make it right? Z value. So we replace our population variances by sample variances. Z is equal x bar 1 minus x bar 2 minus mu1 minus mu2. Make a square root. Square root of S1 square over n1, S2 square over n2. Now this is your case number 2. Case number 2. Case number 3. Case number 3. Case number 3. Populations are normally distributed. So the population variances are known. Population variances are known for small samples. Unknown. Population variance unknown for small samples. For small samples. Small samples. What is small samples? N1 less than 30, N2 less than 30. What will happen? X bar 1 minus x bar 2, x bar 1 minus x bar 2, x bar 1 minus x bar 2 does not follow the normal distribution. Now again T distribution with mean mu1 minus mu2. What is your variance? S1 square over n1 plus S2 square over n2. Make a T distribution. Now we are going to calculate T value for that. T is equal x bar 1 minus x bar 2 minus mu1 minus mu2 over square root is 1 square over n1 plus S2 square over n2. Arakema extension. So then you extend your sample mean. Case number 4. Case number 4, non-normal populations, central limit theorem. Case number 4. So you are going to sampling from non-normal populations. Case number 4, populations not normally distributed. Not normally distributed. not normally distributed, and with known variance, sigma 1 square and sigma 2 square are known. For large samples, sampling distribution of sample, difference between two sample means are approximately normally distributed, approximately normally distributed with mu1 minus mu2, sigma 1 square over n1, sigma 2 square over n2. For large samples, non-normal populations. Now this is approximately normally distributed. Z value x bar 1 minus x bar 2 minus mu1 minus mu2 over square root sigma 1 square over n1 plus sigma 2 square over n2. Now this is your case number 4. Case number 4, case number 5, case number 5. Populations are not normally distributed. Populations are not normally distributed. Not normally distributed. Sigma 1 square and sigma 2 square unknown. Large samples. Make it happy small samples coming there. For large samples, in 1 greater than or equal 30, greater than or equal 30. So x bar 1 minus x bar 2, approximately normally distributed with mean mu1 minus mu2, s1 square over n1 plus s2 square over n2. Z value. This is again approximately normally distributed. Now these are the 5 cases, extension of the single mean. Single mean extension mean so then you construct all these distributions and so Z values extend. So then no need to memorize it as with other, so it becomes too complicated. Difference between two sample means. What about that? තේරුණාද ඒ ටික අරක extend කරන්න කටපාඩම් කරන්න එපා. පුළුවන් නේද? extend කරගන්න මතක තියාගන්න පුළුවන් නේද? sample mean එක extend කරගෙන. So can you make these distributions? පුළුවන්ද? අර ටික හොඳට මතක තියාගන්න sample means කියන එක ඒකම දික් කරලා ගන්න. So these are the distributions for mu1 minus mu2. Are there any questions? මොනවද තියෙනවද? අහන්න. Are you okay with that? ඊළඟ එකට යන්නද proportions එකට? මොකද මට ඒතර අද මේක ඉවර කරන්න පුළුවන්. 2.4 එක ඉවර කරන්න පුළුවන්. ඊළඟ එකට යන්නද? Next one, sampling distribution of sample proportions. Next one. ඊළඟ එකට යන්නද මේකේ මොනවා හරි ප්‍රශ්න තියෙනවද? තේරුණාද මේක? Have you got understood this?
Okay, madam. We'll go to the next.
Okay, right. Then sample proportions. මේකත් ගොඩක් වෙලාවට ඉන්න ඉඩ තියෙනවා as sample mean. Sample mean එක වගේම sample proportion එකත් ගොඩක් වෙලාවට එන්න පුළුවන් ගණන් වලින්. Sample so this is the sample proportion means. So then with qualitative the variables male, female, defective, non-defective and ඒ වගේ. So now this is according to the central limit theorem for large samples, sampling distribution of sample proportions are approximately normally distributed with mean mu p and variance sigma square p. එතකොට මේකෙදි sampling distribution of sample proportions do not have any conditions. ඒකට හේතුව තමයි the reason for that is so then the like this, what you call it? This is like a binomial application, male or female, defective, non-defective, correct, incorrect. So in binomial, can you remember the normal approximation to the binomial distribution? So we are considering only for large samples. එතකොට මෙතන අපිට condition එකක් නැහැ. Population is normal or non-normal. So only thing you must take only a large sample. Large sample එකක් විතරයි අපිට ගන්න ඕනේ. වෙන කිසිම දෙයක් මේකේ ඕන වෙන්නේ නැහැ. So then here it is not important in case of mean. So then populations are normal or non-normal, variance known or unknown. මේ කිසි දෙයක් මෙතන ඕන වෙන්නේ නැහැ. Only for large samples. Right. What are the notations? එතකොට ඕගලන්ට මේ නම් මම හිතන ඕන වෙන එකක් නෑ lesson 1 එක I think so අර ඉස්සරහට තියෙන නිවාඩු දවස් දෙකක් තියෙනවා lesson 1 එකේ revision එකත් arrange කරනවා මම ඒකට එන්න කැමති අය ඉන්නවා නම් ඕගලන් කවුරු හරි මේ වෙලාව times ටික දාන්න there are this weekend Saturday Sunday දවස් දෙකේ so then 28th and 29th of September. So then of the lesson number 1, that is random variables, normal binomial distributions, and ඒක මම ආපහු කරනවා. ඒක දායි ඔයගලන්ට message එකක් තව කවුරු හරි වෙන දෙකකින් ඉන්නවා. Sample distribution of sample proportions. Proportions. So notations are notations. So mean, expected value of sample means we denoted them as mu p. Variance, VARP, sigma square p, standard deviation or standard error, square root of VARP is as sigma p. Now these are the set of notations of sample proportions. The notations used. Right. So what are the common properties? Make a common properties. We occur properties. You can make it. No any cases are there. So what are the common properties? Common properties are mu p is equal pi. So its mean is equal to the population proportion. Its mean is equal to the population proportion, and its variance is equal. Pi into 1 minus pi over n. What is the binomial distribution again? Variance again. NPQ. Q කියලා කියන්නේ 1 minus p. මෙතන n එක නැතුව නිකන් PQ over n. So now this is your variance. The mean of that sampling distribution is equal to the population proportion. Variance is equal population proportion into 1 minus that divided by the sample size. එතකොට අපි මේක අන්තිමට ගන්නවා. This is again approximately normally distributed. So sampling distribution of sample proportions. Only condition is for large samples. We have to take all only large samples. Make a vitrai condition. Sampling distribution of sample proportions are approximately normally distributed with mean population proportion pi and variance pi into 1 minus pi over n. Pi into 1 minus pi over n. But if this is approximately So Z value is equal P minus 5 divided by square root 5 into 1 minus 5 over n. Now this is regarding sampling distribution of sample proportions. Its mean is denoted as mu p. Its variance is denoted as sigma square p. Standard error is sigma p. So now what are the common properties? Mu p is equal pi. That is the population proportion, and its variance is equal population proportion 1 minus then divide by sample size. And not only that, so under only the condition for large samples, it is approximately normally distributed. Make a normal distribution. So then it does not follow any T distribution. T distribution. So we are taking only large samples. T distribution again is small samples. So then it is approximately normally distributed with mean pi and variance pi into 1 minus pi over n. So then Z value is equal P minus pi square root of that. May tamai sampling distribution of sample proportions. Easy, no any conditions. So then very easy properties, common properties and no conditions. Araki tamai inne for population is normal or non-normal.